Hey friends, welcome to the YouTube channel All About Electronics. So in this question, we have been given that the voice channels with a 4 kHz bandwidth are multiplexed together. And here, to avoid the interference between the two channels, the guard band of 1 kHz is also kept between the two channels. Now all the channels are amplitude modulated, and here the total bandwidth of the channel is equal to 1 MHz. So here we have been asked to find the number of voice channels that can be multiplexed in this 1 MHz bandwidth. So here the bandwidth of the each voice channel is equal to 4 kHz. Now we know that once the channels are amplitude modulated, then the total bandwidth of the voice channel will become 8 kHz. That means after the modulation, the bandwidth which is required for each voice channel is equal to 8 kHz. Now this type of voice channels are multiplexed together in the 1 MHz bandwidth. So let's say 3 such voice channels are multiplexed together. And here, to avoid the interference, the guard band of 1 kHz is also kept between the two channels. So in this case, if we just take the case of the 3 channels, then the total bandwidth which is required to multiplex 3 channels is equal to these 3 times 8 kHz plus 2 times 1 kHz. So in general, if we multiplex such n number of channels, then the total bandwidth which is required for the channel is equal to these n times 8 kHz plus n minus 1 times 1 kHz. So this is the total bandwidth which is required to multiplex n number of channels. And here we have been given that the total channel bandwidth is equal to 1 MHz. So from this we can find the number of channels that can be multiplexed together. So in this case, these n times 8 plus n minus 1 is equal to 1 MHz, or we can say that it is equal to 1000 kHz. That is equal to 9n minus 1 is equal to 1000 kHz, or we can say that 9n is equal to 1001. So from this, if we calculate the value of n, then it is equal to 1001 divided by 9, which is equal to 111.2. So if we consider the integer number, then the value of n will come out as 111. That means in a 1 MHz bandwidth, we can multiplex total this number of channels. So with this value of n, if you calculate the total bandwidth which is occupied by the multiplex channel, then it is equal to these 8 times 111 plus n minus 1, or 110 times 1 kHz. That is equal to 998 kHz. And since it is less than 1 MHz, so this number of channels can be easily multiplexed in a 1 MHz bandwidth. So from this we can say that for the given question, this D is the correct answer.